Hi guys, today we are learning 6.10 monomial square roots. This finishes out chapter 6 for us. You guys will be able to write equivalent radical expressions. So this actually builds on what we have done previously in 6.9, except now we also include variables in that need to be simplified. So, notes examples. Square roots with variables. Square roots with variables are also known as monomial square roots. That's where our title comes from. Just like numbers, variables can be simplified. So we have our given here. If m is a multiple of 2, use the rule the square root of a to the m. We just divide by 2. If m is not a multiple of 2, for example, it's an odd number, we break it apart into 2 pieces. Okay? This will make more sense in a minute. So, simplify each radical. There's 2 ways you can think about this. See how this is a multiple of 2? It's an even number. You can just divide that by 2, and your final answer is x. Another way to think of this, and how I like to teach my students, is to think that x squared is really just x times x. There's 2 of them. Because it is a square root, I'm looking for groups of 2. So if I have a group of 2, I can take that group, one of them out. So my final answer then is just x. So if we look at question 2, it'll work the same. We'll look at that way first. This is actually the square root of m times m times m times m times m times m. There are 6 of them. We are trying to find groups of 2. 1, 2, 3. There are 3 groups of 2, so this is equal to m cubed. Now, if you prefer the other way, you just divide by 2. You also get m cubed. Either way, totally fine, totally valid. If we start throwing numbers in, that's great. We can simplify like we did previously. So the square root of 9 is simply 3. And then if we take this divided by 2, we get 3k. For question 4, the square root of 64 is 8. If we take 4 divided by 2 for p to the 4th, we get p to the 2nd. If we look at question 5, the square root of 100 is 10. If we take each exponent divided by 2, we get x to the 1st, y to the 1st. For question 6, 49, the square root of 49 is 7. If we take each of these variables divided by 2, we get a to the 1st, b to the 3rd, c to the 2nd. Okay, hopefully that's making sense so far. That's if we have even exponents. If we have odd exponents or a combination, that's fine. Let's first look at writing each of these out. So this is like the square root of y times y times y times y times y. Once again, we are still looking for groups of 2. So we have 2 groups of 2y. So we have y to the 2nd with a square root y left over. Doesn't completely simplify, but this is as simple as it gets. If you wanted to think about it the other way, if you take 5 divided by 2, you get 2 with 1 left over. So this is where that would come from. So if we think about this next one that way, a to the 2nd with the exponent divided by 2, and 3, the exponent divided by 2, you would end up with a to the first, b to the first, because 3 divided by 2 is 1, with 1 left over, and then b in the square root. Oops, sorry. This is not b to the second, it's b to the first. Don't know why I wrote that. So it's a times b times the square root of b is our simplified form. So let's keep trying these. This next one, divide each of these exponents by 2, which means we have x on the outside, y on the outside, z squared on the outside, and there is 1y left over. If you prefer my other method of grouping them all up, you have x times y times y times y times z times z times z times z. Group them. We've got one group of x's. That's where x to the first comes from. You've got one group of y's. That's where y to the first comes from. You've got one y left over. That's where this guy comes from. And then you've got two groups of z's. That is where z to the second comes from. The next one, the square root of 144 is just 12. Once again, if you like seeing the variables written out, this would be like k times k times k. So you have one group of k's, so k to the first, and then 1k left over. All right, pause the video. You guys really quick try this out. All right, hopefully you paused. The square root of 81 is 9. If I divide my two exponents by 2, I get r cubed s squared on the outside, and there is 1r left over on the inside. For 12, the square root of 196 is 14. If I divide my two exponents by 2, I get c to the second d, and there is 1c left over. So on the next page, the variables are not going to really change much. I just now do not have perfect squares for my numbers. So I'm going to have to simplify more like I did in 6.9. So perfect squares here. I have the square root of 4 and the square root of 2 that go into the square root of 8. I also, if I want to show out my work this way, have x times x times x times x times x times x. The square root of 4 is 2. Root 2 does not simplify. And then I have 1, 2, 3 groups of x's, so I actually have 2 x cubed as my final. I continue on like this. The square root of 50 can be split into the square root of 25 and 2. So I have 5 root 2. And then if I divide my exponent by 2, I just get 1x on the outside. So 5x root 2 is my solution. If I look at 15, 68 splits into 4 and 17. If I write out my p's, I have p times p times p. That gives me 2. I've got one group of p's, 2p, square root 17p. On question 9, I split this apart into square root 9, square root 5. Since n to the 11th power is a lot of n's to write down, I'm actually just going to divide that by 2. 11 divided by 2 is 5 with 1 left over. So I get 3 n to the 5th, square root 5 n because of that 1 left over. (17) The square root of 27 can split into the square root of 9 and the square root of 3. X to the first does not have any buddies to be able to group up with or to divide by 2, so it will be left inside the radical. Y to the 16th is a lot of y's to write out, so I'm just going to divide that by 2, and it comes out to an even 8. So when I take the square root of 9, I get 3. Y to the 8th times the cubed root of x. (18) The square root of 180 breaks down into 36 and 5. Guys, that's just what we were doing yesterday. Today we're just adding the letters, basically. The square root of 36 is 6. Square root of 5 will stay, because it can't be simplified. X cubed, I will divide by 2. That gives me 1x on the outside, because 3 divided by 2 is 1, with 1x left over. And then the variable y to the 8th, if I divide the exponent by 2, I get y to the 4th on the outside. Now, guys, you do have to have these complete final answers. If yours does not look exactly like mine, something is wrong. Go ahead and pause. Try these next 6. Come back when you think you've got them. Okay, hopefully you paused. Square root of 160 breaks down into square root of 16 and square root of 10. Divide my variables by 2, or sorry, not my variables, but my exponents by 2. So I get 4a b cubed times 10a. (20) The square root of 180 breaks down into 36 and 3. Now, if you have been writing out all the r's and all the s's or all the variables, as many of them show up, there's a couple in these next few problems that are going to take a lot of writing to be able to get there. So if you have been writing them out and circling your groups and counting those up, great, that's fine, totally valid. These are just going to take you a little longer. I would maybe try practicing the division of the variables. For example, r to the 18th would take a lot of writing, and s to the 13th would take a lot of writing. So if I divide the two exponents by 2, I am left with r to the 9th on the outside. 13 divided by 2 is 6 with 1 s left over, still inside the radical. It will be with the 3, and the square root of 36 is 6. So I have 6r to the 9th, s to the 6th, times the square root of 3s. 21. The square root of 17 splits into 36 and 2. Divide the exponents all by 2. So I have 6. 9 divided by 2 is 4, with 1 remaining. N 12 divided by 2 is 6, and p to the first. (63) Square root of 63 splits into 9 and 7. Divide these all by 2, the exponents. So 3 is what the square root of 9 is. 5 divided by 2 is 2, so x to the second with 1 x left over. 25 divided by 2 would be y to the 12th with 1 y left over. And z to the 14th would have z 7. No z's left over because it's even. But then there is this radical 7 that I can't forget about there. Okay, so I know it seems like there's a lot of steps here, but you just deal with the numbers like we did in 6.9. Simplify your radicals, and then deal with the variables by dividing by 2 and seeing if there's any remainders. Just make sure you look at every single piece. So we'll finish this up. We do have some bigger numbers here. The square root of 252 splits into 36 and 7. X to the first cannot reduce any, so it will stay inside the radical. Y to the second can just pull out a 1, and z to the third can also pull out 1z. So we have 6yz. 6 comes from here. Square root, we got to bring the 7. And we've got an x and a z left over. Lastly, we take the square root of 392. This splits into 196 and 2. Divide the exponents all by 2. We get 14. A to the first, b to the first, c to the first. Then we have a square root of 2 and 1c left over. If you guys have any summary to add with how you were thinking through these, I would add the summary on your own time. Otherwise, make sure you are working on your 6.6 to 6.8 Delta Math if you have not done that yet. And if you have, great job. Make sure your notes are written down really well, that you understand them. And that's all I have for you today. See ya.